Hi everyone, welcome to this video on concentration in consumer products. The last video we looked at was the one where we looked at how we measure concentration in chemistry, and more often than not we use moles per liter as my concentration. And the reason is it's easy to determine the number of moles of product, and you can do stoichiometry with chemical reactions if you have the concentration of a solution. Consumers have no idea what a mole is. And what they find is very easy is to use is the concentration is expressed as a percentage. So you'll have here, for example, an isopropyl alcohol bottle has 99%. Well, we know what 99% means. If I have a medication, I might have a 4% dosage here or concentration of a medication. So I know that 4% of this particular product contains my active ingredient. So it's very easy to know. Even when it comes to fertilizers for your lawn or for your garden, they have these three numbers, and these three numbers, they represent the percentage. So for example, here, this number 21 indicates that the product contains 21% nitrogen. So when it comes to these products, we want to know how to measure the volumes or masses. And what we normally do is whenever we have a volume, we measure the volume for consumer products in milliliters. Whenever we have a mass, we're going to be using grams. Sometimes we compare the volume of a solute, it's a liquid, to the overall solution. So we've got a percentage of volume to volume, milliliters to milliliters. Other times everything's a solid, so we've got percent mass mass. We have grams over grams. Grams of solid over grams of the total mixture. And sometimes we even have mass per volume. So for many medications, we have that. How many grams of that medication are present in so many milliliters of the solution? So we'll be looking at these and looking at some examples for each as well. So the first one we're looking at is volume. So as we said, many times you look at liquids, two liquids mixed together, it's easy to compare the percentage of the two. So we use a volume percent. And you look at the volume of the solute over the volume of the whole solution as an example. So let's take a look at an example here. Sorry. So in this particular situation, what we have is we've got rubbing alcohol. Now rubbing alcohol, in this case, has a concentration of 70%. Let's going to add an extra zero here to make it easier for significant digits. So my concentration is 0.70% volume. Now, what else do we have here? What volume of isopropyl alcohol is used to make a 500 milliliter container of rubbing alcohol? So what I have is I've got the volume of the solution. The whole solution is going to be 500 milliliters. Remember, consumer products use milliliters, so it's okay to leave it like that. And what I want to know is I want to know the amount of alcohol that I need to produce a 70% solution that has 500 milliliters in it. So like before, the concentration in this case is the volume is going to equal to the volume or the amount of the solute. Here's the alcohol over the amount of the solution. And both of these are going to be in milliliters. So what we know is this. We know that my solution is 0.70, so 70%. I don't know the volume of the alcohol, so I'm going to leave that there. I do know the overall volume of the solution is 500.0 milliliters. I actually have an extra significant digit here too. Now we're going to simply solve now. So 0.700 times 500 milliliters is going to give me my volume of the alcohol that I need. And do a little bit of simple math, you end up with 350 milliliters of alcohol is required. So these questions are fairly straightforward. Just need to have a little therefore statement here. 350 milliliters of isopropyl alcohol are required. And I'm just going to abbreviate the required so I can squeeze it in there. So again, it's just like before, it's the amount of solute over the volume of the solution. The only difference is both of them are volumes, okay? And we use milliliters here. So let's look at another example. So what I have here is I've got a trumpet, and a trumpet is made up of brass. So brass is made up of alloys. So we're going to be comparing the amount of the different metals in here to the overall metal solution, we'll call that. So because both are solids, we're going to be using the mass percentage here. So it's just like before, except we're comparing the mass of the solid over the mass of the solution. So let's look at the example here. So we have here brass is an alloy. It's made up of 85% copper. And I want to know how much zinc is present in a 150 gram sample of this brass. So what I know is I know the concentration is 0.85 mass. So we're looking at grams over grams. And I'm looking at the whole solution. So the brass here, sorry, the mass of the solution is 150 grams. And what else I know is I want to know the amount of zinc in here. So the mass of the zinc. My problem is this. The 85% is for copper. It's 85% copper, but I'm trying to find over here the mass of the zinc. So you got to be careful here. I got to do a little bit of math here. So I know that if my entire 100% is the mixture, 85% of it's copper, so the rest of it must be zinc. So basically, I just do a little percentage here. So brass is 100%. It's equal to the amount of zinc plus copper. I know the amount of copper, so then I can figure out the amount of zinc. So it's 15% here. So I can't actually use this concentration. I'm going to have to use the concentration that corresponds to zinc. So 0.15% mass zinc. So I've got everything I need now. So let's write down our equation. So our equation, remember, is the amount, is the concentration. So here the concentration is 0.15 percent mass zinc. And it's going to equal the mass of the zinc, so a solid, over the amount of the whole solution in grams. So it's just like before, except we're doing grams. So then we just simply do a bit of math here. 0.15 times 150 grams. It's going to give me my mass of the zinc. And with a little bit of magic here, let me see here, with the calculator out, we end up with 22.5 grams for your mass of zinc. So it's very easy. So basically it just says that 15% of the 150 is my zinc, which equals 22.5 grams. Let's do a little therefore statement. So it looks like we've got two significant digits. So therefore, the mass of zinc is, now with two significant digits, I'm exactly halfway. So we have to round to the even number. So in this case, the even number is 22 grams. So here we use the even number rounding rule. All right. And we're almost done. We just have one more example to go through. So sometimes, especially when it comes to medications, we're going to have percentage, but percentage mass over volume. We have the number of grams of solute in the number of milliliters. This is often seen in medications. So it's a mixture of the two we had before. Oops, let me go back a little bit. Here we go. So the example we have up, oops, there we go. So in this particular situation, let me just erase the previous solution. What we have here is I've got 250 milliliters of distilled water, and I've got 2.15 grams of a drug that I'm adding. The overall volume is going to be 3.65, and I want to know the percent mass volume of the solution. So what we're looking for, the percent mass volume, it's equal to the number of grams of solute. So the mass of the solute over the volume of the whole solution. So what do I have here? So I know that the mass of the solvent or solute is 2.15 grams. The volume of the whole solution, I don't use this. I use the 3.65. That's the total volume. And what do we end up with here? So at the end of the day, you get the calculator here. I'm just going to pause. End up with, where is it here? 0.589 as my percentage. So therefore, the percent mass volume concentration is 58.9% with 3 significant digits there. Okay, let's do one more quick example for this. Sometimes we have slightly different things. So what I have here is sodium phosphate. It's a solution to clean walls. It's commonly used by painters. And here the concentration is 1.7% mass volume. I want to know what's the mass of sodium phosphate needed to make a 2-liter solution. So the first thing we have to do, we have to write down what we have. So I know the volume of the solute, or sorry, solution. So volume of the solution is 2 liters, but I can't use 2 liters. I have to use milliliters in consumer chemistry when it comes to percentages. So 2,000 milliliters. I know the concentration, so the percent concentration mass volume is 1.7%, which we're going to rewrite as 0.017. And I want to figure out what is the mass of the solute that I have to add. That's the mass of the sodium phosphate. So let me put that down. Phosphate, okay, which I don't know. So let's look at our equation. So the equation we have, the percent mass volume, is the mass of the sodium phosphate all over the volume of the entire solution. So I know this is 0.17. I don't know the mass of my sodium phosphate, but I do know the volume is going to be 2,000 milliliters. I will do a little bit of simple math. We end up with 34 grams of sodium phosphate. And with how many significant digits? Looks like 2 significant digits. We're done. So basically the mass of sodium phosphate is 34 grams. And we're done. So again, let's quickly recap. All of these consumer percentages are relating to the concentration of these products. Some of them are just volume, where we use milliliters. Some of them are just mass, where we use grams. Some of them are more combinations, so it's the number of grams per milliliter, but they're all percentages nonetheless. And that's it.